Right, let's take a look at this problem. Least number of unique integers after k removals. So we want to remove the uniques and then least, okay. Given an array of integers array and integer k, find the least minimum number of unique integers after removing exactly k item elements. So we don't have k. We have to remove k many of them. All right, so right. So what are the cases? I mean, if I sort it, not sorted, but like if I sort it based on the unique counts, like if I have from if I have a list sort if I have a counter array, and then this will be like my counts, okay, and then if I sort this counts sort based on key lambda the values of it, so key counter get or like lambda x and how do we get the x value? So counts x. Okay, I guess it's like this. Or maybe if I use get, will that work? Return counts. Let's see. Alright, not counts but 0, and here print counts. We don't have this sort. They sort it based on that. Just 1 second. Right, so I'm back. It looks like we cannot sort this, but if I turn this into a list, now what happens is that lambda x, I get counts x1. Right, so actually maybe try this. Right, so when we sort it, it is basically So you have to get it like this. It's actually like I said, but right, let me do it like that, I guess. So sorted counter reverse is true, and here key should be lambda x, where x, we look at the x1. So maybe let now try it. Actually, we should get the items like that. Now we get items based on, it should not be true. I should get the least one first. And then I simply go over this for every, or like while k is greater than 0, continue, and every time I decrease it by 1. So every time there's two possibilities. If I have k by 1 at the end, then return the length of counts. So now if k is equal to how do we do this? So we have counts 0, the first element, and the second. This is the frequency of it, or like frequency, maybe like that, and then the number like that. So we have that numbers, unique numbers, number actually like that. Okay, so I have my number and frequency like that. So if my frequency is greater than or equal to k, in that case I want to remove the current one, which means that k should be minus frequency, but also I want to remove the first element, but to pop it, actually we want this for every, actually this should be like reverse, should be true. Now here I want to start from, so I will be equal to length of counts minus 1, and every time I want to decrease I by 1 until that, or and I is less than, greater than 0. It can be equal to 0. Okay, so we get the number. So this is now basically, we again start from this. Now if frequency is 1 equal to 1, then I decrease it by 1, and if my current frequency is larger than or equal to, actually if it is equal to it, it will differ, then just return then counts minus 1, because we just removed that one. You don't have to remove it, but if you remove it, then it will be len counts. And then here frequency is greater than k, and then else it will be less than k, which means that I want to remove the current one, which means that I will just decrease I. Yeah, and then also I want to pop counts pop, which is constant time. I want to pop that element, and then I also want to k should be decreased, frequency should be decreased from k, and here if the frequency is larger than k, we just return the length of less because we don't even have to decrease that. We just return it because it means that the remaining case, even if we remove from the current elements, they say that 5, if k is 1 and we have only 5, 5, then if we remove one of the 5s, we still have one unique 5. So that is the counts here. All right, let's see if this works. So it says that this is not subscriptable because this should be -1. Actually, it should be I. All right, so counts. All right, now if we change this to that, let's see what happens. It also works. Maybe change the inputs again to maybe just remove 3 of them. 1, 1, 1, 1. What happens? It works. What about this? K should be always greater than that. All right, then 1, 1, 3, 1, 1, 2, 3, 4. 1, 2, 3, 4 should be 1. Okay, let's submit and see. Okay, it works. And so counter is of n. We sort it based on those values, which will be of n log n. So this will be n log n, and this is just of something which is less than of n log n. So I can just say that the time complexity is of n log n, and the space complexity is of n. So we sorted, we created actually unique elements u, where u is the unique elements we have. Anything else, and then we pop it here, which is all 1. We have the length counts. Yeah, this should be my answer to this problem. Alright, so that was it. I'm actually curious if there is a better complexity way to handle this. Looks like there maybe this. Oh, but with buckets. Alright, I'm not gonna go over it because I think this is pretty good solution to this problem. So I'm just gonna close it now. Anything else I want to add? No.